everyone. I'm Michaela Parker, founder and executive director for the Academic Data Science Alliance, and I'm here to welcome you to our virtual session. Today, we will be hearing from Anat Caspi, who's the director of the Tasker Center for Accessible Technology, and she'll be talking to us about non-ableist data science. But before we get started, I wanted to give everyone just a little bit of background on the Academic Data Science Alliance, or ADSA. We are a community of data science researchers and educators who take responsibility for a just, equitable future where data science approaches are thoughtfully applied in all domains for the benefit of all. Now on this slide in the bottom right is a QR code that'll also appear on the subsequent slides. You can snap that and it'll take you to our website where you can learn about our events, activities, our mission, vision, values, and how to become a member. And with that, I thank you for joining us. I'm now going to introduce Anat. Dr. Anat Caspi is a principal scientist in the Paul G. Allen School of Computer Science and Engineering. She's also an affiliate assistant professor in electrical and computer engineering and a director of the Tasker Center for Accessible Technology, all of these at the University of Washington. The mission of the Tasker Center is to develop, translate, and deploy open source, universally accessible technologies with a focus on benefiting individuals with motor limitations or speech impairment. So with that, I'll turn it over to Anat, and the floor is yours.
Thank you so much. I am so happy to be here, and thank you for the invitation. Of course, it would have been preferable if we were in person, but today, I will do my best to foreground the ideas of non-ableist data science and the specific workshop that we were working towards presenting at the in-person conference. And I will be presenting today. Michaela did a wonderful job introducing me. I wanted to say that this is the shared work of other co-organizers of this workshop, including Abraham Flexman, Richard Ladner, Jimmy Huang, Anissa Tanwir, and Anushka Zalami. And we are all, well, were at the University of Washington at the time of the conception of this workshop. The Tasker Center specifically works on taking research specifically in data science and machine learning and finding ways to apply them and bringing them to the hands of individuals with disabilities with the idea of improving quality of life and day-to-day friction with barriers in society. And so a little bit of what we're talking about today are issues that we confront in our day-to-day practices of taking some research products and turning them into translatable, deployable artifacts. Let's see if this will actually advance. Okay, so speaking today, we want to talk about how data science can be made more inclusive of both practitioners and consumers of all abilities. And the workshop we had originally run in 2020, it was done in a much more participatory way. And so I would encourage you throughout, I will also show a QR code, which invites you to both comment on the specific parts of the data science pipeline, which we will discuss today, but also asks you if you're interested in becoming part of our community of practice that addresses these questions, as well as whether you'd be interested in running one of these workshops or a lunchtime conversation at your organization. So please feel free to make contact with us either through that forum or directly contact me if you would like to use our resources for running these internally to your organization. And we would, of course, appreciate your feedback in the form of a survey or even being interviewed afterwards. So there are obviously many people currently working on problems associated with biases in data science and in AI. And our focus here is a little bit different in terms of centering disability in the discussion of bias in data science, because it complicates the dominant approaches to the discussion of bias in data science. And it also complicates the way we address these challenges. disability studies and the disability rights communities have had many discussions and disagreements over issues of what is discrimination, what is bias, what are the means by which technology in general, not necessarily just data science, mediates a lot of disabled people's experience in the world, because technology is often used both to alleviate as well as contribute to some harms that people are experiencing in society. And so that's one aspect of why looking at the non-ableism in data science has its own specific nuances. Another aspect of it is that data science bias debate engages many concerns that actually affect people with disabilities in specific and very acute ways. And these include issues of privacy, of consent, and also the high stakes of being misclassified in the context of having asymmetric power relationships, for example, between patients and doctors. So at the most basic level, excluding considerations of disability and also excluding considerations of the scholarship of disability and the discourse that it's providing us can mean that efforts to address data science biases don't actually include people with disabilities, and therefore they're potentially more likely to experience harm and marginalization as a result. So while we're looking globally at biases in data science and the data science processes, we want to remind people that inclusion doesn't only have to go along with axes of gender identity, race, ethnicity, but disability should also be foregrounded. And that is really the purpose of having this discussion. So in our past conversations, we did a little bit of surveying, and we tried to understand who is in the room as far as data science practitioners. And you see here that predominantly people who disclosed that they practice data science in a professional way were part of the conversation. And then we had people who didn't really have a sense of what data science is. We had a lot of people that align themselves with a particular disability population, but really the predominant people that attended our workshop were people who practice data science either as a hobby or professionally. And of course, I would love to survey you, but we won't do that today. I think for better practices, I would love it if you participated in our community of practice. And then the next question that participants were asked were about their specific experience and relationship with disability. So what we'll do today is a little bit different. The flow will be me kind of introducing the purpose and what it means for us to adopt this non-ableist lens. And then I will talk through a simplification of the data science pipeline, which is using a set of cards called the AI blind spot cards, which we'll discuss in a minute. And then finally, I would love to have some people share their concerns, questions, or work in the chat, which is what I believe we have available to us. And likely we have that survey, which we would appreciate you participating in. So the basic premise that we'll adopt here is that data science is obviously increasingly important in producing knowledges and producing technologies that impact a lot of people on the daily level. And how we perform data science in terms of how we analyze the data, design analysis tools, deploy systems, and also publish these data-driven conclusions makes real impact on real lives. And I think I don't need to say that in this room, but when the data science pipeline ignores variations and discrepancies among humans, it can bias that decision-making process and the outcomes, and therefore has the potential of negatively affecting people and people with disabilities in particular. So in order to bring everyone together, we didn't want to make this conversation drawn out of the ether or just theoretical. But I do want to take a moment to define a couple of ground words or terms so that we're all in the same page. So we're not going to define AI or data science, but I'd like to scope the conversation to cover, for the purposes of this workshop, that will refer to data science as the practice of deploying computational, potentially statistical methods to derive patterns, elicit insights, or make predictions through the use of data sets, and typically large ones. And of course, you can refute this in various ways. And of course, there are nuances to this, but this will kind of lay the groundwork of what scope we're talking about in terms of the processes that inform these systems that are then disseminated. And a subtext to this conversation is that the majority of widely deployed data science systems are deployed by commercial entities with large business enterprises. And the reason that this is particularly important in the case of addressing biases against disabled people is that heterogeneity within the disability population is great. And addressing any one of many accessibility concerns might not actually seem as profitable or having the business case, so to speak. So while we're here talking about the process of producing data science products that are disseminated, and we hear often about the work of industry and researchers to conduct, participatory design and include people with disabilities in their practices, the big flag here is that we're not actually addressing how and in what contexts these are being deployed in terms of like looking at those business cases. And the fact is that a lot of times saying we do participatory design can serve as a kind of smokescreen in the sense that it doesn't actually allow people to have the power to meaningfully shape or reshape the technology, because it might be acknowledged that if you're building these technologies, you need to have participants involved, and we as data scientists might actually include people in that process. There's no stipulation about the actual power that they have in shaping the results or the resulting technologies that get disseminated. And so the barriers to having access to that power, especially in industry, is that often those technologies that serve a small community just aren't profitable or meet some kind of mythological scale benchmark that a lot of these companies require in order to work on a particular problem. And so even if they're included in the pipeline, that might not have real life implications on these systems, but I'm saying this is kind of outside our scope for today. So insofar as today we're only looking at the processes of generating data science products, we want to examine like the data science process itself, rather than those other contextual and structural barriers that may stand in the way of producing non-ableist data science. So I'm going to constrain our conversation even further to talk about process bias. So if we have a process, we need to define what that is. The process of data science produces knowledge and technologies that impact us daily. And so it's a direct output of some kind of pipeline. As data scientists, we plan data experiments, we collect data, we analyze data, we design analytic tools, we learn data models, deploy algorithmic systems, make inferences, produce data-driven predictions or conclusions or reasonings. And each one of those steps can be potentially interrogated for ableist bias. And I'm trying to sort of propose that we do a tiny, tiny bit of that today. So to get us further on the same page, I'm going to, sorry, I saw that there was something in the chat, but it wasn't to me. So let's define that process bias. We'll take a critical lens to examine these procedures that produce data science products. And while we really aspire to like distill and automate reasoning and judgment that's aligned with what we call intelligence, a lot of algorithms are still very simple, imperfect models that are susceptible to making erroneous assumptions. And so we have to acknowledge that our models are fairly simple and reductive. And so that's sort of a basic assumption that we're making here in this conversation. Other assumptions or definitions that we will consider here without actually having the discourse about it is what is ableism. So ableism we will define here as a systemic bias that privileges individuals who fall within the range of non-disabled. And the word non-disabled is intentionally used because we don't want to talk about typical people, normative individuals, because it excludes disability from the conversation. So non-disabled in some way puts the otherness onto the population that is considered within the non-disabled range. And so minimally, ableism is just a discrimination on the basis of ability, either perceived ability or actual ability. And that is per Campbell's definition. But we can also look at ableism as a set of social and political structures that end up marginalizing and subjecting people to differentiations in the power structure. And they can shape discourse and undergird institutions in some very pernicious ways. As far as what we will take as our critical disability lens, by taking on the critical disability lens, what are we actually doing differently than simply interrogating bias in data science processes? Like, why is this any different than taking a critical anti-racist stance, for example? Well, as we noted, people with disabilities are a heterogeneous population, so there's very little to substantiate a construct that glums everybody together. And while our understanding of race and gender is similar in these ways, even among those who identify as having the same disability, unlike people who identify as having the same race or gender, there are multitudes of identities and also result in significantly different lived experiences. And AI systems and data science systems may misrecognize or fail to recognize those distinctions. And so disability theory in general helps our conversation here, not as any sort of factual, scientific, or medical classification by giving us some kind of definition of disability, but rather looking at disability as that construct, a cultural, historical, political phenomenon that we have to contend with when we think about bias in our data science pipelines. So really the questions that we want to ask ourselves are what kinds of design, research, or data science practices could produce more desirable futures for people with disabilities, and how can we assess the effects of these practices? Like, how can we actually measure or understand what are ways to change the course of the outcomes, and what are other systemic interventions that might be needed beyond those that are just focused on the technology itself? So again, like looking at that bigger context. Those are some of the questions that we want to ask. And here again, we'll emphasize the social construction of ability and also recognize that the material and psychological impacts of being labeled as disabled can set people outside what is considered to be Western cultural norms. Okay, so how do we turn this theoretical discourse into practicable, critical exercises that we can take as data scientists? So the co-organizers and I thought about this a lot, and we decided to adopt a tool, and I'm gonna skip through these two slides, a tool that from the get-go we identified as being rather imperfect, but it had the prescience to offer opportunities for growth and modulation. And so this tool is called the AI blind spot cards, and it was designed by Anya Calderon, Dan Tabor, Hong Chu, and Jeff Wen. And it was part of the 2019 Assembly program, which I'm sure some of you are familiar with. And we chose to work with these cards in order to give our workshop participants a concrete object that points at the data science processes and can serve as kind of like a prompt, but still keep in mind that the ultimate goal is just to draw out ideas through a discussion or your comments, not to fixate on the cards as a specific solution to biases in data science. So that's important to remember because it can seem like overly reductive. So in our original workshop, we had small group discussions after this point. And now instead, we will just go through some of the cards, and I will try to identify some case studies that are applicable to those portions of the data science pipeline. And what I would encourage you to do at this time is, as we go through the cards, this is the QR code for the survey that basically asks you for comment on a specific pipeline step in the pipeline. And so it's simple, like 4 questions, and offers you the opportunity to give us your contact information if you want to be included in our community of practice, and or just gather some of the resources that we've produced for people to run these workshops internally to their organization. So, and if you don't feel like dealing with QR codes, this is the tiny URL. It's non-ableist data science comment. Okay, so going to what are actually included in these cards. The cards attempted to break down the pipeline into like 3 major categories and then some specific steps within the pipeline, specifically planning, building, and deploying, with the entry into the discovery process being purpose. And so as we went through these with our participants, what we encourage people to do is actually to add in aspects or steps in the pipeline that were not included. And we called those joker or wild cards because we can always add additional aspects. So things started with just purpose. So data science systems should really, in ideating on what is the purpose, try to refine the specific ideas of what it is that we are trying to accomplish. And do we really need data science for this is one additional question. So there are actually 2 aspects to asking questions around purpose in applications of data science as it pertains to ability. One is that, as we noted, AI marketing a lot of times invokes disabled people, presenting all kinds of images of AI as an assistive technology designed to help navigate their disabilities and negotiating barriers in the world. And in fact, there are many examples of technologies that are used in assistive ways by disabled people in one context or another. But very often, the processes by which these systems were created don't actually include that lived experience of people with disabilities. And the benefits that are professed by the marketing endeavors fail to actually manifest how it is that this reflects the lived experience. And it's often an afterthought or like a pretext or like a disability dongle. For example, for years, developers reinvented systems for American Sign Language recognition that really failed to be comprehensive or useful at all. And it also almost seems to me like every year there's like another trope out there about another ASL recognition system that in large part are produced in exclusion of deaf people or people who know ASL, and really are just generative, like system development and design about just understanding specific signs without understanding the wide contextual breadth of ASL so itself. So that's one aspect of purpose, right? How are we actually typifying or identifying the purpose for which this technology is designed and doing so inclusively? But it's also important to note that, as mentioned in Carl Bergstrom and Jevin West's course on Calling Bullshit, they identified a case in which in 2016, researchers had posted an archive paper called Automated Inference on Criminality Using Face Images. And in this, the authors explore the use of machine learning to detect features of human faces that are criminal. And they claim to have developed a model that can use a simple headshot to distinguish criminals from non-criminals with high accuracy. And obviously, the ethical implications here are quite frightening. This begs the question of, what was the original purpose of actually building this system? Because typically, what we saw in the outcome of this build was that faces that may have been disfigured or not have normative patterns or not have symmetry were more likely to be identified as criminal. And of course, that has specific links with a whole history of looking at disability as deviancy and deviation. And so this really underpins a whole host of concerns about what was the real original purpose in building the system? Was it really this kind of dystopian science fiction, which is scary in itself? Or did they stumble on this and try to figure out a way to pose a purpose for a model that learned something, perhaps for publication purposes or something like that? So looking at purpose and why this artifact came to be and why it's published is really one of the main concerns here with the purpose card. The next one is actually something that was proposed by our workshop participants, and one of the breakouts was specifically trying to point at scope and context. So what are the contextual boundaries of what we're trying to accomplish? Are we collecting the right data to accomplish that objective? And when investing in a particular project, are we investing in the mitigating effects of inequalities? Or are we potentially running a risk that the infrastructure will fail to provide proper answers and affect any kind of legitimate change? So many times, I think the scope of data science is to save costs. There are a lot of times economic cases for different situations, but the bottom line is that without resources, you can't do anything. And so the scope and context is really important here. And institutions that are influencing large-scale data infrastructure often have resources, but it's just a question of what are their priorities. And when investing in a particular project, you're not just investing in a business case. It's really, that needs to be clarified in the arena of industry using data science. And recently, Tim Cook actually in a large gathering pushed back when he was presenting iOS and new accessibility features in iOS, and somebody in the crowd pressed on him to explain the business case for this. He basically said, if you're investing just for the business outcomes and profits, you shouldn't invest with us. And that's pretty powerful coming from Tim Cook, but certainly I think other individuals and entities that are using data science and models in order to cost save in their institutions should be thinking in the same direction. And so one actually very different case in terms of like what the industry is, but potentially also scope and context misguided, is that in 2017, the Boston public school system wanted to redesign the start times of their schools because there were scientific studies that showed that teens need more sleep. So in order to cost save, essentially, they had to identify the optimal start times for everybody, because they have to shift the younger kids' start times to earlier in order to accommodate later start times for the teens, so that their bus fleet, for example, can accommodate everyone's needs. So they would take the younger kids to school first and then return and take the teens to school. And so they needed to optimize those bus routes to accommodate those new start times. And they, I'm not sure how they harnessed the help of MIT graduate students to construct an algorithm to go through the novum trillion options. That's one followed by 120 zeros, different options that the algorithm had to go through to identify the optimal one and trim the district's budget for the bus routes. And so the algorithm had serious blind spots in terms of the full context of who they're serving, how this might change the landscape for parents who have to work, and the differentiated start times will seriously cause difficulties for them in accessing their work and economic opportunities. And so having the context and scope of your problem fully understood is very important. And of course, the Boston school system had like 85% of upheaval in parenting, in parent backlash, and families just didn't agree to that change. So that wasn't exacted, but of course you can identify places where they don't have this kind of feedback mechanism, and so they might not know that they're harming families. And in particular, we can think about families of students with disabilities that take that have a number of different people and components involved in the getting of a student to school that were impacted by this kind of blind spot to the scope. Any questions on this? I know it's weird for me to be talking about this without the feedback, so I'm just calling out others. Okay, so still talking on planning. How do you identify when you have representative data? Was this data science or AI system trained on the same communities who will be potentially affected by the system is obviously highly relevant. And if the data used to train, for example, a pedestrian recognition system doesn't include representations of people using scooters or people using wheelchairs, it's likely that these people would not be recognized as pedestrians. And an example of this was in 2018, an autonomous Uber riding car in Arizona killed Elaine Hertzberg, who was a pedestrian pushing a bicycle when she was killed. And a recent National Transportation Safety Board investigation found that there were significant problems with Uber's autonomous system, including the failure to recognize pedestrians outside of crosswalks in general. And the investigation also found that Uber's system had a hard time classifying Hertzberg when the car first detected her, but 5.6 seconds before impact, it did classify her as a vehicle. And then it changed its mind to other, and then to a vehicle again, back and forth. And so you can imagine that if she was not pushing a bicycle, that may not have cause for the misclassification. And so was it absolutely, well, is it the case that representative data was not presented in front of this system in order to properly learn a model that would detect all pedestrians? And another example or important case that comes out of this is really about the data collection and the labeling, because a lot of data science systems, you don't really think about, the use of mechanical Turkers as the labeling mechanism for a lot of these data collections. And there's a lot of literature about the potential misunderstanding of terms, of methodologies, and of classifications, and some actual problems with having Turkers as your labeling system because of the lack of consistency, standardization, and potentially, the motivation here is to consume the greatest amount of work and rather than produce good data necessarily. So I won't cover all that data here, but literature is pretty well described about, I don't know, outside, okay, you're still seeing my screen. So it's very much the case that we should think deeply about how we pursue the data collection, whether we're using surrogate data for something else, and whether our labeling mechanisms can really achieve the validity that we really pin on them when we use them as the gold standard for our learning systems. So at this point, we kind of bridge over to abusability. So again, still in planning, but during your planning stages, you probably want to consider whether this system is vulnerable to attack by potentially bad actors and who could potentially be harmed in this way. In this case, I like to bring up a case study about HireView, which was a system deployed for hiring. And the purpose was to diagnose interview subjects as disabled without consent, based on methods that were not necessarily scientifically grounded. They had these ideas about how their neural network could detect similar features across multiple videos of people who identify as disabled, and they found some pattern of behavior, potentially speech, tone, other markers that correlated across videos of disabled people. And the system was then used to detect disability, or at least to identify those patterns, right? So again, talking about representative data, they didn't have any real definition of disability. They just identified some patterns, but it classified them as disabled. And the patent's authors claimed that this system was intended to reduce discrimination and bias against disabled people during the hiring process by identifying them. But by adjusting the automated job performance score that were assigned to people detected as disabled, there was really no guarantee that it would actually be used in that way, right? It's very much the fallibility of humans that might take that information and abuse it in ways to cause harm or discrimination. And significantly, this was done with no consent for those individuals who were applying for the jobs and supplying their video to the would-be employers. So the next step in the consideration and planning of a data science pipeline is privacy. And given the serious consequences of deploying data science systems and AI systems that really tend to reproduce and amplify our data, so whatever data we give it, it will amplify those systemic decisions that are made, and likewise systemic exclusions that are potentially made by the data that it's provided. We do want to have scholars and advocates calling for the increased collection of data that represent people with disabilities. For example, having rare illness cooperations. In France, for example, was created to collect data from different members in the hope of better understanding and addressing their health. So we're able to collect that data and learn from it. However, we have to think about the privacy and security concerns of having these as open participation methods for data collection in people with disabilities, because it could be risky in contexts where healthcare is not necessarily guaranteed, because the harms that are resulting from these potential disclosures that people are making by contributing their data could actually result in discrimination in other systemic or structural ways in their environments or through policy. So for example, you can imagine denial of coverage or employment by just having found a person in one of those databases as a particularly pernicious kind of way or use of that private data for harm. So privacy considerations are important. Moving on to the actual building of the data science systems, one of the parts of the pipeline is ensuring that there's no discrimination by proxy. And of course, in here, you kind of think about how an algorithm can have an adverse effect on a particular vulnerable population. And it may or may not have specific protected characteristics that you would be able to name, right? So you may remove race identity from the data set, or you may remove gender alignment, or you may remove self-disclosure of disability, but then there might be some other attributes that can be used as a proxy to model that because those features are potentially correlated with those hidden attributes. So what we want to guard against is a data science system that's biased against certain communities, potentially due to proxy characteristics that may show up. And one of the things that we really think about when it comes to this is how people identify, self-identify and disclose, and in a way to take notions from a totally adjacent kind of enterprise, which is the Diagnostic and Statistical Manual of Mental Disorder, the DSM, is a standard reference for psychiatric diagnoses. And there are so many people and groups that fought both to be included in and to be excluded from this DSM because of the way that their potential group can be mischaracterized or misunderstood, and having this social consequence of being labeled and defined by others in a particular category is particularly pernicious and exclusionary for many groups. And so what we want to explore here are specific cultural understandings of ability that might threaten to close off some opportunities for significant change by fixing old categories into, like, baking them into our data science systems in ways that we can't easily shift or reject. So that's a really kind of a big one. And one of the questions that we pose in the workshop is actually, how can we identify ways, possibly performance characteristics and metrics, to identify potential discrimination by proxy by identifying some of the attributes that might be used as a proxy for these groups that are that are not being used as descriptive characteristics of people. The next point in the pipeline, again with building, is how do you build explainability into your pipeline? If the results are potentially a black box, how can we overcome those? Could the data-driven decisions that this system makes be justified? And of course, the logic of algorithms is often complex, which make a lot of recommendations unclear. And in designing and deploying these systems, we do have a responsibility to explain high stakes decisions. But how do we do this when the model itself says very little in terms of how it derived, how it identified the weightings of different attributes or features? I'm thinking specifically about some of the convolutional neural networks that we talk about often, and there's very little explainability that we can derive other than things that are extrapolated. And so then some of the questions we try to ask is, what are some ways to overcome that? Are we only about analyzing the outcomes and providing some explainability at that endpoint, or just providing full transparency on what the model is doing and how to deploy it yourself? So different scholars recount different tests of AI models designed to guide different industries, and in the hope of understanding how it can perform when it encountered people who fell outside the norm or did things in unexpected ways, which is kind of aligned with people with disabilities. So to do this, researchers expose the model to different kind of data that might fall outside the representative data. And when they present such data, they test to see if they have full confidence in understanding what the outcomes of those data science models are. But reflecting on a lot of these experiences out there, it's important to say that we need a whole host of these tests, not just anecdotal tests, in order to determine the full explainability of the model and the data science products that are out there. So the next step is actually, how do you design this optimization criteria, which is such a hard question to begin with. Like when we take data vectors or a host of training and testing data, how do we determine what our cost function is that we're trying to optimize? And of course, this has huge bearing in terms of what the outcomes of this system might actually do. Likewise, in other kinds of analytic applications, what are these functions that we're using as proxies for reasoning methods or identifying patterns in a particular data set? This is especially important for populations with disabilities because so often the optimization criteria make very strong assumptions about the Gaussian nature or normal distributions of some of the attributes that we're looking at. And by definition, people with disabilities typically fall outside the, two standard deviations from the norm. And so addressing these questions goes way beyond just identifying our biases in the purpose and planning for these systems, but very specifically at the very core of what we assume data science to do, which is to identify normed patterns in the data. So this has a very specific and potentially huge impact on the lived experience and outcomes for populations with disabilities when it comes to algorithmic bias and data science biases. So to me, this is at the core of what data scientists, theorists who want to expose bias in AI are trying to do. And so this is really where the quantified methods of identifying alternative ways to look at data and data analytics, but really all of these other aspects that we're talking about today are parts of the pipeline that we can address and look into. So now we verge into the last portion of the pipeline, which is really about how we present our conclusions and results from the data science process. And so generalization error between building and deploying the system, conditions in the world can obviously change. We already spoke to the fact that the models themselves are highly simplified and not representative. And so how do we guard against generalization error? And in particular, in the case of diagnostic cases where we're trying to classify people, say on the autism spectrum, or document different ways of classifying individuals when it comes to determining what their eligibilities would be for social assistance, we see a lot of generalization error potentially out there because there are cultural biases and omissions and many false positives when it comes to essentially data points that are outliers to what the algorithm learned. So in a way, it's related to the optimization criteria, but that generalization error is something that we come across very often when it comes to disability bias and data science, because false negatives often are burdensome and fall heavily among populations with disabilities. And before I go to the last one, this is the last one that was offered as part of the AI blind spot, which is the right to contest. So asking whether people have the opportunity to actually contest the decisions that were made by these systems. Like any human process, systems carry biases that make them imperfect. And having that right to contest a decision can surface different inaccuracies and actually give agency to people who may not have been part of the process earlier on. But of course, this goes back to the ability to give people the refutability, the ability to contest it, and say that you may have diagnosed me in this way, but really I don't identify with that diagnostic, and therefore might not go through this intervention in a particular way. So these have real life implications, and we have to offer people the right to contest. Most recently, for example, from my own experience, I was sitting on a panel defining data standards for eligibility requirements to access the transit system. And nobody was sitting there and actually thinking through, like, what happens if the data science process somehow misallocates someone outside of the eligibility criteria where they actually do have eligibility, and how are they made, what is available to them to contest that automated decision was not even thought of as part of that data standard, which it really should be. So we really have to think deeply about the right to contest when we deploy these systems in the wild. And lastly is one of the cards that was offered by our workshop participants, where it was all about presentation, visualization, and dissemination. We have to make sure that the decisions and determinations and analytics and dashboards that are made by systems are legible and visible to everyone, so that people can actually understand what is being done by the system and have visibility on the outcomes. Whether or not they contest them, having that understanding is really part and parcel of what we do as data scientists. And so there's no harm in making our outcomes more presentable, accessible through non-visual or non-audio terms. And it really benefits us to be able to present our work in multitudes of ways and forms, even to deepen our own understanding of what our system is doing. So with that, I will ask you once again if you are able to connect to this form. And I saw that the link was posted in the chat, which I appreciate. Well, I didn't want to put readable. So a suggestion was that readable is better than visible. Because sometimes there are visualizations that may not be, that could be descriptive, but not necessarily explained in words, but maybe both readable and visible would be important to use. Oh, I went back, sorry. So what I ask you, I'm 2 minutes over, I apologize for that. Join our community of practice, join these conversations. You can offer up your own way. Perhaps you completely refute the way we've broken this down and are actually have ideas about how we can improve the way we digest ideas around biases in data science, and particularly ableism in data science. And we do have collateral and material for you to run your own workshop. If you're interested in that, also use that form, or I will put my, I don't know if you can actually see what I'm chatting, but I'll put my email in the chat so that you're able to contact me. And thank you so much for your time. I don't know if we do or don't have time for questions, but I'm happy to take any if anybody wants to stick around.
There is one question from a while back in the conversation.
Because I wasn't tracking everything.
Did you see that? Yeah, it says it's been an interesting aspect of Zoom hiring calls that it is not always obvious when people have mobility disabilities. So the choice to disclose has sometimes shifted in time. So sort of a comment there about experiences.
Right, so does the person who commented on this think that's actually a potential improvement in our data systems, that now one is not forced to disclose visible disabilities right away because there's no potential appearance of them in the initial stages of hiring?
Yeah, we might hear, oh, they're raised. People in the hiring process are asking mentors when they should disclose. So that's interesting. It's sort of a new frontier in terms of trying to navigate disclosure timing.
So my experience as both being in the hiring process at a government institution of the University of Washington, where, you know, we're not allowed to pose those questions anyway. It's possible that, given that I work in the accessibility world, I've seen more people with disabilities apply to our jobs during the pandemic. So perhaps that filter is giving people greater confidence in approaching the hiring process first, or potential. You know, I don't believe that I'd seen more resumes previously that had more disclosures than currently. But of course, I have a very small N in this. But I do think that there's some aspect to having that virtual filter, at least initially, that provides people with greater confidence in just applying for those positions. Right.
We have a question in the Q&A. I don't know if you can see those, but I can just read this off. How may we include people with disabilities data in data sets without putting their privacy at risk? Any thoughts on best practices of building inclusive data sets?
Yeah, that's a really tough question. So our approach is to kind of approach it head on in a way. I think because data analytic practices, as I said, are so entrenched with the assumptions of like Gaussian distributed attributes, there's just no way to have representative data sets. Even if you amplify your data with populations with disabilities, that amplification can cause for, other kinds of biases. So in a sense, I think one of the two solutions, one is to really probe our use of Gaussian models. And the second is to specifically address populations with disability as a separate data population where there is heterogeneity, and it will break your models for sure, but that's the point, right? And then we can proceed from there. That's kind of my take. One thing that is important, I think, is to first identify ways of collecting these data sets in ways that are not just accessible to the population of interest, but also guards from discriminatory practices.
That's great. Any other questions from attendees? I
went a little over.
It's pretty quiet out there. We're seeing a little bit of a drop off, but
fair enough.
Okay.
Yeah, I went a little over, but I appreciate everyone's interest.
Yeah, thank you. And we may follow up with you and have a discussion about running the workshop in person if we ever
I love that. Yeah,
get to be in person again.
I'll have my peeps show up too, because then we can really have some meaningful breakout conversation.
Lovely. That would be
very
great.
lonely to do this from this purview, but thank you for the opportunity. It was fantastic.
Yeah, it's been really great. And I'd like to remind everyone who's still hanging around that next week we have, as Michaela said at the top of the session, a double header. We've got two of our data science conversations happening, one on Wednesday at 12:30 Pacific, Boston University and University of Chicago, and the second on Friday at the same time with Bowie State University and Winston-Salem State University, both talking about challenges of standing up data science programs at our institutions. But thank you all for coming, and we look forward to seeing you next week or at an ADSA event in the future.